Hello, this is Stas and welcome to my new TouchDesigner tutorial, and this one would be about making perfect loops, or if you prefer this term, seamless videos. And by that I mean video where the last frame and the first frame is about the same, so if you play it on repeat you wouldn't see any jumps when the video starts and start playing again. And for creating patch for making these perfect loops, the easiest way, of course, is to create the patch with intention of making a perfect loop. So you do all of your chops and organize all of your chops in this way. But sometimes there is another situation when you have patch that made without this intention, and or maybe you port some shader with a lot of dynamic variables or something else. And for example, here I have the noise is run by apps times seconds. Here I have some parameters run by beats. Here my camera goes around with LFO ramp with this frequency. Here I have some colorization with another ramp with different frequency. So it's absolutely mess. And I'll show you how to take something like this, or maybe some shader, it doesn't matter, and change it in a way to make this perfectly seamless video. And if you're interested just in the technique, you could skip the next part, because now I would talk a little bit about how this network is organized. Maybe this tutorial is not about making this effect, but maybe some of you interested in this. If you don't, just look in the description. I leave a timecode there, so you could jump straight to the perfect loop part. Okay, and if you're interested in how this created, let me turn off so we wouldn't be distracted. Okay, I start with a box. This point cloud top created by converting SOP to chop and then to top, and if you look at the point, it's just a cube, this 16 by 16 by 16 points. And here, so if I'm, let me try to show it. Oops. So if I connect this to the position, I would get just a normal cube with some flickering, and I tell you about flickering a bit later. But to make it more interesting, what we have here, I have some noise with the same same amount of points. Here I have 96 points, and here I have the same. And then I go to pixelate to organize my noise into blocks, because if I wouldn't do this, the noise would create an effect where the cubes goes everywhere. And with blocks, it's organized in some kind of abstract architecture. And the amount of pixels in the blocks comes from this setup, where they have a table with 4 different values. I select one by using this count chop. This goes from 1 to 4, and this value used to select the row goes to that, and then it feeds this value. Okay, and I'm using also quantize value to make the size perfect. If you want details about this, I have a tutorial about point clouds. It's described there. I leave a link in somewhere in the notes it should be in the right corner of your screen. And as a comp, I just switch different operation, and for this setup I choose exclude. Not because it's the best one, it's just I choose this. And for making this pulsating, I'm using the same beat. So on the same beat we have this a little bit contraction on one of the axes, and at the same time this pixelate values changes. Okay, so what else? Here I have the HSV adjust to make it a little bit more saturated and more bright, and by threshold I'm selecting some of these values, just some very bright, and multiply it and use it to feed as a additive color in my geometry instance color mode. And this gives me a different color for some of my blocks. So most of my blocks is the same color. So if I turn this off, it would be all the same colors, and if I turn it in a different direction, some of the blocks with different colors. And it's also used the same selection used for making the offset of this colored block. And this because if I wouldn't offset it, here's I'm just adding to position to make an offset, very tiny offset, like 0.003. If I turn this off to 0, I would have what's called the Z fight or Z buffer fight, when we have two primitives with different colors, and they should be displayed on the same plane, on the same points. So these two different colors fighting with each other what to display, and the render is not very smart and display it like this with a lot of flickering. And to prevent this, all you need to do is to add a little bit of offset, so it wouldn't be on the same position. But if you add a big offset, it would move your values. So I want a tiny bit, and by trial and error I figure out this for this setup 0.003 is a good value. The lower than that I still have Z fighting, and the higher I would get a large offset. Here I have a little bit of offset, but it's okay. Okay, what else? Yeah, for instance, I'm using the box. And for camera setup, it's just the camera goes on this path, cam path. It's just a circle transformed to, let me show it to you. Okay, here is my circle for my camera. So camera moves here, and I'm using this LFO ramp for feeding the position, and the position 0 and 1 is the same position, so it goes in the circles. Let me close. This the camera look at 000, but actually in this network probably it's not very important. And as a light, for lighting I have only environment light with this default provided by Touch file with this sea landscape with a little bit of blur, so I wouldn't see the very sharp clouds as a reflection. And I have PBR material with some metallic without any scratches, dirts, and anything. Okay, here I have a render, and I also render normals. Maybe you didn't know how to do this, so on a render on advanced page you increase the number of color buffers. Here I need 2 color buffers, is the first one, is the second one. And on the material, on advanced page, you set what to show on the color buffers. The default color buffers is default rendering, and the second color buffer number 1 is you could choose something like a normal map, texture coordinate 1, or camera space position. And in my case I want normals to use it also for the colorization, post colorization. And here I have a very simple setup with a hue offset that goes from 0 to 360. Composite, black background, and that's it. And everything runs in different rates. So let's go outside. Let's copy and call it perfect loop. And let's start. And to make everything a little bit more interesting, I would say that I would also want a soundtrack. And I will use the well-known sound. Maybe you hallucinating it right now. I could put it up. Yeah, but yeah, I don't want to hear it now and mess with my voice. So I want this, it could be of course any other track, and I'll use the info to get the track length in frames. So in this case I would like to use to make a video with 4218 frames, so it would match the length of an audio file. But of course you could choose any other length. For example, if you want 1 minute video for Instagram, that would be a loop. So you set here 360, 1 minute. Here 60 by 60 is 3600. Forgot how to say it in English. Okay, 360. All right, anyway, you got it. But here I would say 4218. It would be the length of my loop. And here I would also like to choose a fraction as well. If I'm working with audio, I would like to set this as a lock to timeline, so audio would play according to my timeline. And yeah. So the basic idea here with this setup would be, where is my select? Here I choose a fraction. So this fraction is 0 in the beginning, and in the end it's equals to 1, almost 1. And I would set any, and I would like to change any values according to this fraction. Most of the time I would use pattern chop. For example, let's start with the camera because it's super simple. So actually with the camera I could just multiply it by 360 and feed it to the camera. So let's just do that. Camera, let's use, or actually let me also have a little bit different setup as well, just to show you a different scenario. For example, if you don't have music, you could set the length of your timeline here in the end and end, and choose the timeline chop. Here you need the frame and end, and if you divide it, channels divide, you get the fraction. It's almost the same because it's not the same because I think because this audio is not perfectly matched the timeline. I'm not actually sure why it's not the same, but it's about the same. And in so here you have another fraction. Let me rename it as a fraction as well. Rename, call it fraction. Okay. And let me use this fraction as my camera. Chop 2, and I need to multiply it by 360. Okay. So at least my camera should move. Let me see. It should move. Whoa. Oh no, we don't need to multiply it by 360. Sorry. I think it's an angle, but of course it's not an angle. It's a relative position in this circle. So the circle is 360, but we here we need just from 0 to 1. Okay. Sorry. Just a fraction here. And when we go here, everything is seamless. All right, that was easy. Let's move to something more crazy. For example, here I have a beat. The beat goes every 8 beats, and the tempo is 110, so 1 beat every 3 seconds. So here we have a pattern. We need a pulse, and as a length for our pattern we need the end of our timeline. And here in the pattern we could choose how many cycles do I want. For example, I want 15 beats. And probably I don't want the first beat just in the start, so I move the phase a little bit. So now what we need to do is to use a lookup chop. Lookup, the first input is a fraction, and the second input is our pattern. It would be much easier to see with, for example, sine. So the lookup goes shows you the sample that match this fraction. So this the whole pattern is the length of a 1, and the sample of this fraction is this have this value. Okay, let's go back to my pulse. And let's call it pulse. Let's call it pulse. And I would use it instead of this bit. I don't like to use the very long spaghettis, like goes from here to here, so I would prefer to use the select. So I need to change it here and here. And this automatically will change both of the table selection and my contraction. So it also right now should be seamless. Okay, what else do we have? Here we have here we have 360. Okay, let me show, for example, a different approach. For example, in the pattern you could choose the ramp, and I want only one ramp without any phasing, for example. And I want amplitude by 360. I need another lookup. Let me call it here offset. And actually I could change it here, like lookup. This hue offset is reference to LFO2, and now I could reference the different operator and delete this one. Okay. What else? So this one is we don't need anymore because now we have our camera, our HSV, and now we only thing that's left is the two noises. But actually I figure out that for the offset I don't need a moving noise, so let me decolorize this. So here it could be a noise with static noise. Okay, so we need to do something with this noise, and let's use my audio here, because what I also wanted to show you is one little trick I figured out just a couple days ago. Sometimes if you run a noise by some audio, you don't use the uniform change in noise, uniform the fraction, like if I set this fraction here, not here, but yeah, if I set just uniformly linear function as a noise, the noise would be changed linearly, like here. But sometimes when we're working with audio, it would be nice if our noise reacts to this audio. But first let me show you the idea about noise itself. If you're interested in details, noise, where is the noise? If you're interested in details, you could check this tutorial by Simon or Polyhop in Instagram. And I'm using his idea. This is circle. This circle. how to explain this. Okay, again, if you want a really explanation in details, just watch his tutorial and I'll explain it very fastly to you. So let's imagine the circle here in my noise. Circle here, and in different points of this circle we have different values of our noise. So we could feed this value as a seed or as any input for noise or for anything else. But these have two coordinates. In two-dimensional coordinate system, it's x and y. And when we, so it would be non-repetitive noise, and when we complete the full circle, we would be in the same noise point, so with the same value. So this is the idea, and it's different from a scenario when we, for example, if we choose, if we pick noise here, we could also set the constraints and set the start and end values the same. But if I'm right now time slice this, we need to change. Oh, really could just repeat it. Okay, let me pick an end, and it should be a frame, and maybe the period should be a little bit more. So if we set this as value, sometimes it goes backward, sometimes it goes forward, and even though it's seamless loop, because it starts and ends in the same value, and it could be different, it could be 1, it could be anything. But for the noise, it doesn't look great. So instead, we would use the circle, and the way to create circle is to use, let me use the pattern so I don't need to, so I wouldn't need to set the length again. Here I would use the sign, and the number of cycles is equals 1, the phase is 0, and here I would use and here I would change it to TZ, and here I would use TW, because we would use a noise in 4 dimension. Like here, in my example, you could imagine the circle here with 2-dimensional noise. But if we work in many scenarios, it would be very visible. It would be about the same as if we, let me turn off this. I don't know, did you use this method before or not? You could also change noise by rotation. And when it goes to 360, it would be the same position. But in this scenario, especially with point clouds, you would notice that the noise moves in the circle. And the same if you use translate on x and y parameters. That's why we set our noise as a 4-dimensional noise, for example, simplex 4D. And now we will create our circle. Look up 1, look up 2, and merge. And it goes from 360, we don't need this, 1 is good enough. And in the end we maybe also need a math. So let me now show you how it's looking. Here I'm setting TZ here, and for translation in the fourth exit, So here is my noise. Let me scale it a little bit less and make it a bit more visible. So if we go to the end and to the 0 and to the last frame and to the first frame, it's the same position. Okay. But now it changes very uniformly, with uniform speed. And you could set a different speed by multiplying these values. And if you multiply, you still have the same beginning and end, because it would be just in my circle example, it would be, for example, the 1 would be a small circle, the 3 would be a big circle, but it's the same idea. But it's uniform. And what I figure out, maybe you already forgot what I started to say. Sorry. So what I figure out that you could use, if I said the mono, it's not necessary, it would be just easier for me right now. Quite often I'm using the RMS power to drive a noise. And as you can see, it's not uniform, it's corresponds to the, not the volume, but the power of a sound. So it would be nice if noise moves in this tempo, in this rhyme. How to do it? How to connect this to our idea of perfect loops? So what I figured out recently is that if you said, usually you use, the usual approach is you set next speed, then maybe a math, and use it to drive a noise. Okay. And what I figured out recently is that if we set the real time to on, or if we just have a very stable frame rate and no frame drops, and if we reload this and reset the speed, and every time we would end up with a very same value here. Every time when the song is over, here would be the same value. And you could even add some other, let me actually add a limit here, and quantize it a little bit to the floor to 0.1. That's good. So what we need to do is we need to check what is this value, what's ending value here. Let's reload this and reset this. By the way, it would be nice to make some component for some setup for this. We need a frame, and we need expression, and expression should be my input value equals to 1. So this expression would be 1 only when our frame is 1, and we could use this to reset. We would reload sum and reset speed. So we could start, it connects, and if we rewind, everything is resetted. Very simple, but don't need to press a lot of buttons anymore. Okay, so let me play it once from the beginning to the end, and we check what the value we'll have here in the end. And as you can see, this value now it's not linear, but with some interesting interaction with the music. But we need to know the ending value, so we need to wait till the song ends, and then we could use this value as a new type of fraction. So our fraction would be not corresponding to the length of a song, but corresponding to the maximum value of this our audio analyzing component. And we could right now use a math. Oh, actually here we already have a math. So let's wait. And yep. So the ending value is 10.94. So if we divide this to 10.94, we would expect to have a 1 value. We need, yeah. Maybe we have a little bit more. That's because it's not actually this value. You could press the letter P or show exact values and see that the actual value is a little bit more. And so you could change it to with a more precise value. Actually, maybe with my plus and minus frames I messed up a little bit, but okay, it doesn't matter. I hope you understand the idea. So we need to play the song once and get this precise value and set it to the math. And now we could use this as a fraction. Let me rename this as well to fraction. And to show you the difference between the linear and non-linear, let me now, what do I need? I need just to do another lookups. Actually, I thought this tutorial would be rather short, but it seems that I need to tell you about a lot of things here. But I hope you don't mind. Let me copy paste it Oops, disconnect and use here math 6. Whoa, what's going on? Oh, okay. Now let's compare these two noises. And let me turn on a little bit of sound. Maybe a little bit more volume, so you could hear. So as you can see, this noise changes linearly, and this a little bit more jumpy according to the music, and it looks much more interesting. So we want this setup. And as I said, with a real-time flag on, it always ends in the same value. And now we will check it when it stops playing. And then we would need to use it for our noise here. Okay, a little bit more. Oh, couple seconds more, and we finished. Yeah, as I said before, I messed the previous time I messed a little bit with pressing this frame backwards, frame forwards, but believe me, this value would be the same if I do it again, but I don't want to do it anymore. And actually when I did test before recording tutorial, I already have this value here, and you could see is the same value. Even though I recreate the whole network once again, I still have the same value, and this is good. This means that this technique works. Okay, but we don't need this noise, we don't need this anymore, and we need this thing, the whole network, to drive this noise here. Okay, we need to change my noise to simplex 4D, and that, and here. And now all we need is to change the multiplication value if we need more noise or a little bit less noise. But I think it's, yeah, maybe it's too fast. Yeah, 1 is good enough. Yeah, it's looking good. And the only problem with this approach that because it's not right now, it's not based on the fraction, but it's based on this the whole setup. We couldn't check it. We couldn't check our seamless idea if we don't wait until the end of this line. But we could do it. We could do it. And we could actually, I could show you that is the same. So that's our last frame. And let's make a difference. Let's pause, let's loop. And here our first frame, which just a tiny bit different because the camera moves and everything the same. But as you could see, this is very seamless. everything, not the colors, everything is the same. So we achieved what we wanted. Well, at least I wanted to achieve this, but I hope you will find this idea useful as well. And as I explained before, you could use this in any other network, and me myself usually use this approach for the JLSL tops for remarching, like here. For example, here I have different parameters for the pulse, for the colors, for the moving, and it's also seamless. And the only difference that you fit all these lookups not to the different chops and tops and comps, but to the some uniforms, some samplers, and etc. So okay, let's see how this looks. Yeah, everything seamless. We could now just record it with a real-time flag on, and that's it. So I hope you like it. Press a button. You could, oh, by the way, if you're interested in this network itself and maybe figure out a little bit more about geometry, you could become my supporter on a Patreon, and for the Patreon supporters I'm always given the project files for all of my tutorials. But of course it's not necessary. It's not necessary, but it would be really nice if you do. Okay, that's it. Goodbye and see you next time. And I'm not sure yet about the topic for the next tutorial. And by the way, let's go to my Patreon, to my posts, and here I have a post with request of different idea for the next tutorials, and I believe it's open for anyone, so you could write your ideas here, and maybe I'll make tutorials with a topic you selected. Or maybe I would be distracted by something else and make something completely different. I don't know. Anyway, I hope you like it. Goodbye, see you, and have a good time.